start. Okay, let me share the screen first. Okay, so yesterday we did some database connection code and I, this one. Okay, so today we'll start with a new topic which is collection framework. So this is one of the most used framework in Java. Doesn't matter whether you're doing any core Java stuff or any framework level thing, this you have to deal with every time. So this is quite big and one huge framework, and we are not supposed to like cover everything from this framework, but definitely certain point which will help us to work in upcoming classes or even projects. So collection framework. Collection, I mean this is actually combination of two words. First is collection. So collection means group of elements. Simple words like group of elements. Here elements are also meant here objects. So we will deal with group of objects, and to maintain their order, their functionality, and you want to perform some operation, all that can be possible through this framework functionality. In simple terms, framework you can say it's a built-in solution. It provides a built-in solutions. So you don't have to work again and rewrite certain things. So it provides built-in solutions. So majorly when we talk about this framework, like I'm just giving example here, examples or built-in framework, not frameworks, just the framework level. We have multiple frameworks in Java. So there was one framework which is already obsolete right now. It's not in development. Like Struts is there, then Hibernate, then Spring framework. So what this framework provides, they provide some built-in solutions. You don't have to work out again. Think about you have to create a web application. So they have some ready-made solutions. Just use it and write your logic, and you can see your project is working on web applications. So likewise, we call that collection framework. So it provides some, not some, lots of built-in solutions to us. Think about we have this programming concept or tools, DSA, data structures. We have lots of trees there, lots of sorting algos are there, maps are there. So you don't have to write logic for it explicitly. Everything is here inside this collection framework in the form of classes, methods, sometimes nested classes. So that's how it works. So collection framework is a group of elements which provides, or by using some built-in solution you can work on group of elements. That's how you can read it. Okay, so before proceeding further, again we have to understand its hierarchy like we did in exception topic. In exception handling we talked about some hierarchy. There was a top parent class and certain child classes were there. Same way collection framework has its own framework hierarchy. So let's talk about that. Then I'll pick some image framework hierarchy images, and I'll just pick this image. Okay, so this is collection framework hierarchy. Cut. I cannot put it here. So let's get a new paint image. Okay, let's do it differently. Okay, great. So this is the hierarchy for collection framework. Again, these are some classes which you need to understand that by using them you are actually working with multiple classes provided by Java library. Okay. Okay. So at the top we have collection interface. So These green boxes are the parent interfaces. Then orange boxes are their child, as we already are aware about in inheritance. So you guys can easily understand if some methods are there, definitely we cannot give the method body. But if some methods are even declared inside interfaces, so all these methods get inherited to the child interfaces. So these orange boxes, they are child of collection interface. And these blue boxes, these are concrete implementation. That means the classes which can be used and their objects can be created. So all the classes which we call concrete class, that means you can create object of it. Okay, so green classes is first. So I'll highlight which class I'm going to cover in my class, and rest of class you guys can cover in your homework. So ArrayList, sure. Then HashSet, linked HashSet, preset, then hash map and tree map. So I will cover these classes in my class, in our training, and other boxes you guys do by yourself. I can highlight them with black color, which you should practice. Linked list, hash table, then from here you can try this priority queue. Not often used, but yeah, if you should know. So try these yellow, what do you call, black boxes by yourself. Okay, so let's pick these classes one by one and see the usage. And you know what, guys? Java provides its official documentation, so you can always check out that class functionality it's working, and even you can list out the methods as well from that. So let's talk about the parent class. We will talk about this red box later. Let's focus on this section: green, orange, and blue classes. Okay, so let's talk about this collection. So we are talking about collection framework. It's different thing. We have a interface. Its name is also collection. Okay, so how to get to know about this class? Collection interface Java doc. Okay, you have to write this statement, and we will end up with uh, the official Oracle website where it manages all the class documentation, and this is its documentation. So how to read it? Just scroll down. If you want, you can read it. Otherwise, you can ignore all this part and start with this. This is the statement: public interface collection something E, which we don't know yet, and then extends iterable. This is the same iterable which we just saw here, iterable, because this is also parent of collection interface. But this is a red one, so we will talk about later. But it also extends some class. Okay, so we are talking about collection interface or root interface in collection framework. And this is its class signature: public interface collection, E for its generic type, which we talk about later, and it extends one interface attribute. Again, we'll discuss it later. Now, going back to the documentation. So what it says: the root interface in the collection hierarchy. Okay, that we already know, but let me pick it. A collection. Now it is explaining what collection is. A collection represents a group of objects known as its elements. So in usually when developer talk about collection or its elements, so it's a, like, sometimes they call this objects, sometimes elements. Don't get confused. Elements or objects, they are same when they're talking. Okay, so this is it. That's about collection term. And okay, there is a functionality it mentions some collection allows duplicate elements, others do not. That's right. It's a behavior or feature which we will see in upcoming topic. What else it says? Some are ordered, some are unordered. Okay, fine. And okay, this is important. The JDK does not provide any direct implementation of this interface. This means collection interface. It provides implementation of more specific sub-interfaces like set and list. So you don't get direct implementation. That means immediately you will see a class. No, there's no direct class to it. If you see, collection is just a root and the child are interfaces. So it doesn't give, that's what it says. JDK doesn't provide its implementation directly, but it does provide for list, set. List has array list interface has linked list, set has HashSet, this has linked HashSet. But when we talk about collection, it has sub interfaces, sub interface or child, both are same terminology. Okay, so I copied this as well. Hyphen, paste it. Okay. This interface is typically used to pass collection around and manipulate them where maximum generality is desired. Okay, find some documentation, so I'll put it here. Just saves my time, otherwise I have to type it by myself. Okay, but there are certain terms which might doesn't make any sense, so that is fine. We have to see that what does it mean. First of all, this at least the term is clear. Some collection allows duplicate elements. We'll talk about later. Some are ordered, others are unordered. So when we write code, then we will come understand these two terms: how duplicacy works and how order or unordered works. And this already explained. This is self-explanatory, and it's a root interface. Okay, so we have a rough idea what this collection interface is and what kind of position it holds. So just a root interface, and it has lots of methods, and we have to definitely talk about the methods because from there we get the functionality. It's just a name. Think about it. If you just create a class car, so you don't get the functionality. You have to write methods like where's the steering, what kind of steering properties it has, how many gears it has, the tires, and the build, the make, paint. All these are features of functionality, right? So we have to talk about that as well. Just by creating a class, it doesn't make any sense. You have to add functionality, and that functionality comes from the methods. Now, one big difference is here, though we have this thing, but still it doesn't give any implementation. It's an interface, and interface are not supposed to give the implementation. So we will see some list of methods again, where on this documentation. So if I scroll down, I can see it says method summary. So definitely there are lots of methods here, but I'll pick certain methods, not all. So first method is add method. So if you want to add explicitly some elements or objects inside it, you can use this method add. Okay, next method remove. As the name says, if you want to remove something, use this one. So that element or that object will be removed. Next method, not this way, add clear. So if you want to clear certain collection, if you want to clear the whole collection, go for this method clear. So elements from that collection will be gone. Go back again. Clear contains, yeah, this is helpful. Whatever methods I'm highlighting, these are the mostly used methods in collection. Okay, contains, it checks whether that element or that object is present or not. Is empty, one of the widely used method. It verifies whether your collection has element or not. So it gives you boolean value, true or false. So if it is empty, it returns true. Okay, empty done. Remove is done. Retain size. Size method. It returns you like how many elements or collection objects are present inside it. So size method. And what else? Splitter, stream, array, leave this. So for now we will use these 5-6 methods. So addition, removal, clear, contains, this we can see. These are some methods present. But again, because we don't have any concrete implementation, direct concrete implementation, so we cannot see the functionality of these methods. So we need to go one level down to check for the concrete implementation. As we don't have it yet, so we will talk about the next interface, list interface, because if I don't have a concrete implementation for the collection, so I'll go one level down and talk about this list interface. Okay, so again we will check this documentation, and here I can see list is here. List, clicked. Otherwise you can Google it like list and space Java doc. Type it and you will get the Oracle website. So this is its class signature. We are talking about list interface. List interface. Okay, and this is its class signature. So what it says, public interface list extends collection. That's a root interface, and that's obvious. List interface is extending the collection interface. There it is, list extending collection interface. That's right. Okay, let's see what feature it provides. I mean, definitely if you have created something new, so it must have some feature. So the very first statement says an ordered collection, also known as sequence. So that means if you're using this list or any of its implementation, so your elements will be sorted. Sorry, not sorted, ordered. Your elements will be in ordered way. Okay, anything else? Yes. Second is this is not important actually, but this is actually a explanation what it meant by ordered collection. Okay. Now next point says user can access elements by their integer index and search for the element index in the list. So it means list also support indexes, that if you want to pick something, just give the index and you will get that element, that object right away. So two important thing we just fetched out from the official document. List interface is an ordered collection. Let me highlight this part, and it is index based. So these are two features of list interface. This is missing in collection. Collection, it gives you some generic functionality or methods, like I mentioned here. Add, contain, remove, clear, is empty size. So these are some general purpose methods or operations which you will do on any collection you have. Doesn't matter either array list or the last class tree map. There are some general methods. But when it comes to specific functionality or features, so that's why these sub interfaces are created. So if you want some list feature, you can go for these classes. If you want some set interface feature, so you can go for these blue boxes, HashSet, linked HashSet. Okay, now feature wise it's done. Now we have to talk about methods. Since list is a child of collection interface, so definitely all these methods must have inherited and definitely they are there. But since it provides some more features apart from what is coming from parent class, so there are certain methods which are not present in collection interface. So add is there definitely, but if you see here, you will notice that add also has one method which provides index. So if you want to add certain element, add certain index, you can also go for it. So here comes the method which is not present in collection interface. So it provides method based on the indexes. So not just adding, but adding at certain index. Going up for some more methods. So add is done. Add all clear. That is same. Get. So if you want to fetch one element, just write this or call this method get, and you can get this element and give the index. Okay. Hash code index of, yes. So index based methods are there. So you can write the object and you will get the index of it, that this element is present at what index. So you can get that. Replace, remove, this is the one. So we already have a remove method which takes object. This remove takes index. So whatever functionality we saw earlier in collection interface, they are already present. Plus it provides some method which takes indexes. Okay. Remove, done. Replace, retain, set, size. Okay, this is fine. You can always try this methods. I'll give you idea because testing and writing code for all methods is not feasible. There are like more than 50 classes in collection framework, and just think about if any class has 5 different methods, multiply 5 into 50. So that much methods will be there. So it's not feasible for any person to remember all those methods and write logical examples for it. So better have an idea how to deal with this, and with these classes you will definitely get some idea. Okay, so we have a methods list. Now going back to that hierarchy. Problem is same. List is an interface. You cannot create its object. So we have to go one more level down to get its concrete implementation. So now we will talk about ArrayList class. So collection is done, list is done. Since they don't have concrete implementation, these interfaces, you cannot create their instance, so we cannot test their methods. Now, ArrayList is child of list. That means all these methods must be implemented inside ArrayList class. So if you create its instance and call these methods, they must be invoked and can be tested. Okay, so the next class or next image is point for ArrayList class. ArrayList class. Okay, it's done. Now let's see the official document again. So going top and there it is, ArrayList. Clicked. Now you even if you see here, let me show you the first of all the class signature. Then I'll show you one interesting thing. That this way, or I'll leave the whole screen is better. Okay, so it says public class ArrayList extends one class abstract list. That's fine, and it implements list interface and some more interfaces: random access interface, global, clonable, and serializable. So these are certain interfaces which are part of ArrayList class signature. Okay, now I was talking about something interesting here. So guys, look at this thing. So at the top we have object class, the parent class. Then we have abstract collection. Then we have abstract list, and then finally we have array list. So this document also maintains the class hierarchy or the whatever inheritance we have here. Let me take this as well for our document part. Okay. About here. Okay, so this is done. If we talk about some features that it has, so let's read some lines. So the very first line in documentation, it clearly says it is a resizable array implementation of the list interface. So we already know what is array. We write some simple examples on it. So this is resizable array. Array has a limitation that you cannot grow its size dynamically. But now we are dealing with collection framework. So the very first feature, it has resizable. You can resize it always. There's no size constraint or limit of it. You can grow its size and at any point while development. Implements all optional list operations and permits all elements, including null. Yep, it allows null as well. So you can add null elements inside this collection. Okay, should be noted. Done. Um, mention this provides okay. This is just kind of a one internal property or feature of list interface. ArrayList class. In addition to implementing list interface, this class provides methods to manipulate the size of the array that is used internally to store the list. So it is mentioning some methods which are already present, and you can use them to store to or change the size of the array list which we have created. So by default, if array list is holding up, let's say 16 elements, so in future you can change it to 24, 48, or according like 100,000, depends upon the requirement. And even after that, you can resize it. So there are certain methods which can be used to change its limit or capacity. Okay, these are some points from we got from the documentation. And now we have a power to write a class, because this is a class, we can create its instance. So now let's code it. So close all, going to create a new package, not run as new package. com.pack.collection demo. Okay, and right click, new Java class. I'll say array list tester. Okay, so our very first example is going to be created. So let's start with main method. Done. Now, how to create instance? We already know, create class name and dot stuff. So my class name is ArrayList. Then reference could be anything, so I'm calling it AL. Then equals, then new, then again ArrayList. Okay, we will get multiple yellow lines. These are kind of warnings from the Eclipse, but for now ignore it. We will also see why that error is coming up. Not error, the warning is coming up, but later. Okay, so we just created instance of ArrayList. So the very first method we saw in collection interface was add method, right? So add method is to, the name says, is to add element where inside collection. So we can use add method. So going back to the collection, so before adding, let's test some other method like size, the last method, which gives you the size of the elements, and we can also verify whether this collection is empty or not. So two things we will do. First of all, let's check the is empty. So how to do that? Al dot is empty, and this gives you a boolean value. So I'll put that in sysout, and here I'll say this, this, and this is array list is empty, question mark. And if I run this code, right click, run as application, and it says, yeah, it's true. You just created a collection, but it is empty as of now. Okay, so let's check the size as well. One more method to verify the same stuff. I can change the message, number of elements. So method will be size, al dot size. So it will show the size of collection, how many objects it has. So right click, run as application, and you can say it says number of elements 0. So that's true, we are getting right information. We don't have any element inside this collection, so we have to add it manually. Okay, so let's do that. So I'll simply say al dot add, and here I can add elements. Let's say 1 and semicolon. Okay, so we just added one element. Now can I execute this code again, I mean these two methods again after adding one element? Paste it. After adding, same way. So let's run this code again, and you guys can see now it is giving false, and now we have number of elements 1. So I can call this method multiple times and put whatever I want. So I have added number like integer value. Let me type some ABC, then boolean value, some float value, some simple characters, and also null. So you guys can see I'm just getting some warnings, but definitely there is no red line. So everything is good with the compiler, and it is not giving any compile time issue or error. Okay, so if I even run this code, this is working fine, and I can print the size again finally after adding all elements. So run as application, and it is giving 6, 1 here and 5 here. So total 6 elements are inserted in the collection. I hope this example is making sense, and we are able to test certain methods which can give us idea how collection works. Next, is some, we also saw some methods. These were some methods from collection interface. Certain method must be left, like contains, remove, clear. Okay, so let's create one more example. I'll keep it ArrayList tester 2. This one, this goes away, and now we already have these scene methods. We can ignore these methods. These methods are used for verifying certain points, or you can use in a conditions, if conditions verify whether the collection has elements or not. Then you can proceed accordingly. So I'm just keeping one method to get the size. And if I run this code, I'm getting number of elements after adding 6. Okay. Now, can I check contains method? Sure. Let's say al dot contains, and you need to pass that collection element, that whether it has or not. So let me check one, or let's say um, ABC. ABC. So you can put any element, and it will check whether this element is present in the collection or not, and it returns boolean value. Does collection has ABC? Okay. So if I run this code, application, it says yes, it's true. ABC is present. If I make it ABCD, not here. Let's have one more line. ABCD and D here as well. And if I run this code, application, it says false. It's not there. Definitely. ABCD is not present in the collection, the existing collection. Okay, it is working. Great. One more method was there. Remove. So if you want to remove, give that method and that element will be removed from the collection. So I can just call al dot remove, and you can pass that element. Let's say I want to remove this 1.2, and then if I verify the size, so initially it was 6, now I have removed 1, and if remove works, great. So we can check the size should be decreased. Yes, it is now 5. Let's verify this as well from this contains method, and I'm checking 1.2. No double quotes, just 1.2 is there. Let's run the code. It says false. If I execute this line before removal, like here, so it gives true. Here 1.2 is true. After removal, it's false. Okay, this method is also working. What if you want to clear the whole collection? Al dot, just call the clear, and all methods, sorry, not all elements from this collection will be removed. So call this, and we'll check this collection again, the size after clear function or method. Here, no, no, size fine. So execute this code again, and there we go. So number of elements after clear, 0. So clear will remove all the elements you have added earlier. So all these things are gone. So that's how collection works. I haven't used index-based methods. So try from your end, guys. Let me know if you face an issue or error. So try indexes, give different unique indexes, and see whether elements are coming or not the way you want. Okay, 6th. Okay, this is done, and the output is right here. This is output. I think I missed something. Yep, just a second. I missed. Okay, fine. So what we just saw, the very first hierarchy, collection, list, and array list. Okay, now let's move to next interface, that is set. Okay, next paint classic. Again, we'll go back to the documentation, and set is not here, not issue. Let's go back. Set is not here as well. it here as well. It must be here then. Somewhere bottom. Yeah, there it is. Set interface. Okay, so like we talked about collection and list, then array list. Something similar we do here as well. Just a second, guys. Okay, so we're talking about set interface. So what set interface provides? No, before that, the signature. So signature is quite simple, straightforward. Copy it. Okay, so public set interface and then extends collection interface. Yep, that's obvious. It inherit the features from parent interface, the set interface. Next is what? The features. So it is one good interface which has one nice feature, and mostly it is used for that. This collection does not contain or provides any duplicate elements, right? So if you are using this collection or this interface, set interface does not provide or contains any duplicate elements. So no duplicate element can be found. So is it true with the list interface or the array list? Let me duplicate one multiple times. Okay, and if I try to do that, at least nothing is coming here up here. So how I can verify whether if I add duplicate elements, so it does affects or not. So let me give you an idea before going to set interface. One more example I want to show you with the array list. Let's get rid of all this part, not needed at all. Okay, then now what we have, this thing, if I run this code, I'll get some elements, 6. Okay, but how to print the elements, right? That's one condition of concern, like how I can print the total number of elements we have here. So what you can do, simply use sysout t and the reference. What's the reference here of collection? AL. Just pass that AL here. And if you run this code this time, elements get printed. You guys can see it has 1 ABC true, 1.2 A and null. So all elements gets printed. Now if I try to duplicate one element, this element. So if it allows, one should get printed multiple times. Run as application, and yeah, it's true. One is printed multiple times. That means ArrayList supports, or basically list supports duplicate elements. But when it comes to set interface, it doesn't provide that functionality or feature. So it won't entertain any duplicate elements. So we will see in a minute or maybe 5 minutes like how it works. Now, more formally, this contains no elements. I can take this one. At most one null element is allowed. Let me complete this statement. So it allows at most one null element. Okay, so let's verify with the list. Is it true with this or not? So I'm going to add one more null element. Oops. Wait. Null element. So I have one element here, null, one element here, null. Let's run this code. So sysout will print the elements, and yes, I can see it takes null element, multiple null values. So list allows duplicate elements, list allows multiple null values as well. Okay, but that's is different case with set interface. Okay, so that's the only feature it has or it provides. So that is fine. What about the class? So we don't have, again, list is an interface. You cannot create its instance. So we have to talk about the next class, that is HashSet. So let's go back to the document. HashSet is here. So we have to talk about its signature first. HashSet class. Okay, so what we have here, public class HashSet extends abstract set and implement multiple interfaces. So extend this and implement these interfaces. And if we talk about its hierarchy, so we can see this is the hierarchy. So at top, it's always object class. Then we have abstract collection class, then abstract set, and this. So that's how it looks like. And let's see its documentation. So this class implements set interface backed by hash table. Actually, a hash map instance. So ignore the bracket for now, but the very first statement is important, that this class implements set interface that we know, which is backed by hash table. Hash table is one of the data structures. That's your first homework. If it's not first or second, third, whatever. Here I can write homework part. So first of all, check arrays. So if you don't know what is, so check what, why we need array, what solution provides, and limitations. So if you know the limitation, then only you will get to know why collection is required. Okay, that's one thing. Now next, this hash table. So check out this hash table. What is hash table? In data structure. Don't go that much in detail, but have some idea. What is hash table? How it works? So you will get to know that how hash table is how or why hash table is saying, sorry, hash set is saying that it is backed by hash table and what function it gets from it. And next point, it says it makes no guarantees as to the iteration order of the set. In particular, or in general, it says it does not guarantee that the order remain constant over time. This class permits null element. Okay, so 2 points are here. Let me pick this. And you know what, guys? If you're dealing with collection, that means you have to uh, cram, I would say, multiple features of these classes. So collection framework is all about cramming the functionality and the methods. And as soon as you start working with writing multiple methods like this way, thinking about what are the features it provides, so you will remember them at least. So usually developers tend to remember what set it provides, what list provides, and what kind of classes it has, and then accordingly we pick at what what's the requirement, and what class should be used at this particular moment. So we have class ready, we have some idea, and I don't know yet like what it meant. No guarantee as to iteration order. So iteration means traversing or reading one element, well, like one by one we are reading elements from the collection. So that is what iteration meant here. Tracking or traversing elements from the collection. So let's do one thing. Let's create a simple class again, like we did for ArrayList. New class and has set tester. Then we will have main method, and I'll create instance of has set. Set. So methods are same commonly used methods. So I'm not going to use all methods. I'll show you some feature functionality here. So has set. Let me add some elements. Dot add. So 1, 2, let's say 10, 21. Random numbers I'm giving. 211, then 500. Okay, so I randomly added some element. Okay, now if I want to print them, so I know how to print it. I can use the reference where all the collections are added. So I can use the HashSet reference, and let's run the code. Now you will see the difference here. Okay, so it prints elements 1, 2, then 211, then 500, 21, 10. So the way we added, it is not giving in the same order. It's different. But if I talk about collection list, this one, and if I run this code, the third one, check the output. I gave 1 ABC true 1.2a. So 1 ABC true 1.2a, then null 1 1 null, null 1 1 null. So ArrayList maintains order, which I mentioned earlier that what order meant here. So list is an ordered collection. So when it simply means the way you insert element inside collection, same way you will get it in the same order. So it maintains the order, but has said it clearly. It makes no guarantee as to the iteration order of the set. Iteration order means the way you will get the element. So when you iterate over the elements of HashSet collection, you will get it randomly. It's all because of this hash table functionality or data structure. So it doesn't maintains order. And what about duplicacy of HashSet? So let me duplicate this 500 two times or three times. So we have now three elements, three 500. Let's run the code and see whether we get duplicate elements. No. Doesn't matter how many times you will add it, you will always get unique elements. What about null? Okay. You know what's the good thing about null is doesn't matter where you will add null in HashSet, it always come at the top. There it is. Null is always there. If I cut or let's repeat it first of all. Does it maintains null? Because of duplicacy, definitely it won't allow another null value. So it's not there. Okay. What if I put it somewhere else? Random places. Let's run the code again. Again, same thing. So it doesn't matter where you put it, null always come at the starting. And it's all again because of hash table. So what we saw, it doesn't allow us duplicate elements, only null is allowed, and it doesn't supports ordered collection, or it doesn't provide the same functionality like you do it. That's about this. What about if I want to print in a, like how many ways are there to print the elements? So functionality wise, we are clear what list provides, what set interface provides. Next is how to, or like how many ways are there to iterate over the collection. So before talk about that, let me paste it in Paint. This is the output. So next question is how many ways are there to iterate over the collection you have in your code. So first we already saw, just print the reference in sysout and you will get all the elements. So let's create a new class for a set. HashSet tester2, close others. Oh, close all कर दिया. Okay, so this is the first way, just print the reference and you will get the elements directly. Next is by using for loop. Okay, so we can use for loop and right click, not run as, what I'm doing, for, and I'll pick this one, for each loop. Okay, and I can simply say sysout and say object. And now if I run this code, you guys can see it is printing, then null, then 1 2 1 1. So we can also print elements by using for loop or for each loop. Next we can also use one more way is there, which is iterator. Okay, so we can also use by using iterator. So by using iterator method. So where it is present, it is present in that class hierarchy we talked about, that I told you that we will talk about this iterable later. So this iterable interface provides this iterator method. So let's verify it. Iterable, there it is, and this is the class, and that's how it stands, public interface iterable. That's it, nothing more to say. Let's create a new interface. behavior attributable interface. Okay, and if we talk about methods it has, so it just has for each, and this method iterator method. This is the way to go. So we can use this method, and since it's a parent of all classes in collection framework plus the collection interface as well, so this method is always there in the hierarchy. So collection, list, and then array list. So this method is coming from this whole hierarchy and comes to array list. So I can call this way. It has a different way to call it. So let's see. So reference is HashSet as well. HashSet then dot iterator. It gives me reference of iterator object, which is a return type of this method, iterator. Then I'll call this itr equals. Then I can use a while loop. Well, this, and then no, this is not loop, and say itr dot has next. And if elements are there, so just print it. If it is there, so itr dot next. That's it. So if I run this code, application, I can get all the elements again. There it is. So by iterator, by using for loop, and let's print this as well by using reference. This is out. Okay, so we just learned the hierarchy and other things as well. Copy this code. See if we can fit this code here. Okay, I need to get rid of certain lines. Okay, better. So we have all the code in our paint image, and we talked about collection, the hierarchy, and what it provides. Okay, let's put the split here. Black. Let's increase the size. Decrease the size actually. Okay. No, actually, I need to run this code again to get that output. Okay, guys, so that's it for today's class. We just learned the way it works. So any question doubt you guys can say, otherwise we can wrap up for today's class.